Assalamu alaikum everyone, dear student. I hope you are fine and doing well. Today my lecture is about discrete log problem, our Z and static. It means to say in last lecture we are discussing uh, discrete log problem about prime residue, and in that case we are discussing more general problem of discrete log based problem, our set of modulo class over any composite number n. So I'm going to do what are the basic conditions under what we can define discrete log based problem over Z and static. So let us define discrete log based problem for Z and static. The discrete log problem that is like this one, let me like this one, if you can say. Discrete log problem can be defined in groups other than Z and ZP static. For n greater than 1, we consider Z n static, the collection of all natural number in 1 to n that are relatively prime to n. That is, Z n static is what we call the consists of all unit element of Zn. That is, k belongs to natural number set, that GCD of k with n is 1. In that case, n and k are relatively prime because this set consists of all those elements of Zn was GCD with n is 1. So let me find the element of Z and 14. We have to choose it from 1, 2, 3 up to 14. All are relatively prime to 14. So Z14 static is consists of all those elements of this set Z14, in which the all the basically unit element of Z14. Z14 consists of all those elements whose GCD with 14 is 1. The GCD of 1 with 14 is 1. The GCD of 3 with 14 is 1. GCD of 5 with 14 is 1. GCD of 9 with 14 is again 1. So GCD of 11 with 14 is 1. GCD of 13 with 14 is also 1. In that case, dear student, you can say Z14 static is consists of all unit element of Z14. So find all the element of Z120 static. So Z120 consists of 1 to 120 elements. So in that case, the Z14 static is consists of all these elements of Z14, in which Z120 static consists of all the element of this set, was GCD with 120 is 1. So the theorem, let P is any odd prime. Zn14 is a cyclic group if and only if one of the following condition is hold. If n is 2, n is 4, or n is some power of prime, or n is the product of 2 into some power of prime. In that case, the student x belongs to 1, 2, 3, 1, 2, 3, and these are all positive power. So determine which of the following group is cyclic. Z128 steric, Z118 steric, Z335 like 3,57,911 steric is cyclic or not. In that case, Z14 148 can be written 2 power 2 into 37. It is not cyclic because it is not what you call 8. In that case, n is 128, which is not like of this form. It is not 2, 4, it is not some power of prime, it is not some product of 2 into prime. This is what you call. So therefore, this is not cyclic. 118, it can be the 2 into 57. Here 57 is prime. So in that case, the second property like this one, third property is satisfied. In that case, this 118 is cyclic. 3 lakh 57,911 can be written as this one. 17 to 71 to the power 3. It is of the form like second form, n is to the power of some k or some x. So in that case 71 to the power 3 is like this. So in that case p is 71 and k is 3. In that case this guru is cyclic. Theorem. Assume that Zn static is cyclic. Alpha belongs to Zn static is a generator if and only if alpha to the power phi of Euler phi function divided by p is not congruent to 1 mod n for each prime p divisor of phi of n. So in that case, you can say in this, like in previous case, we have defined some power of alpha p minus 1 divided by q is not congruent to 1. So here we have defined phi of n divided by some product of what you call divisor of phi of n, which is prime divisor is not congruent to 1 mod n. So find all the generator. Let us take one example. Find all the generator of Z54 static. So Z54 is static because 54 can be written as 2 into 3 power 3. So from previous case where we have defined result like this one. So 2 into p to the power k. So this satisfies third case. In that case, we can say 54 is cyclic. So we can take 54 static, all the element of Z54 which are relative to prime to 54. In that case, there are 18 elements. So you can also compute phi of 54. Phi of 54 can be written as phi 2 into 3. So 2 and 3 are relative to prime, so phi can be distributed. So phi of 2 is 2 minus 1, phi of 3 power 3 is 3 power 3 minus 3 power 2. So in that case 18. You can say this basically there are 18 elements. Phi of 54 because phi of n give you the element of Z54 static. How many elements? So there are 18 elements. If you count this, these elements, both GCD with 54 is 1 are 18. So that phi of n give you the number of elements. Uh, Factor like no, second step is here is 18. So, dear student, if you can say phi of 54 is 18, the factor of 18 is 2 into 3 power 2, a prime factor. It can be written as a p into q or some prime power or product of some prime power. So I can take the prime divisor of 18 are p2 or p3. Because phi of 54 is 18, so I just basically the student I'm just using this result that phi of n divided by p, where p is the prime divisor of phi of n. So if we can take, I take p is 2 because this is the uh, divisor of prime divisor of 18, and this is again prime power divisor of 18. So in that case 18 divided by 2 is 9 and 18 divided by 3 is 6. So I have to check the through exhaustive search you can all the element of the set for two element like first one and 54, these are not generated because rest of we will have to check because whether these are generated or not, because the 1 and 54 are not of big order. It means to say it does not generate all element of Z54 static. So let us check alpha is 5. Alpha power 6 mod 54 is equal to 19 is not, it should not be not equal, it should be not congruent to 1. 5 power 9 mod 54 is equivalent to 54 under mod 54. These are again not congruent to 1. In that case 5 is generated. Why? From where I get this 6? Because if you can divide this, 18 divided by 3 is 6, and 18 divided by 2 is 9. So in that case, I took both power 5 alpha, means alpha to the power 6 and alpha to the power 9, and take it as a, after taking this power and this mod it by 54, I guess 19, which is not common to 1. In that case, 5 is generated. Similarly, I take alpha as 7. In that case, if you can see, say, 7 power 6 mod 54 is not common to 1, but 7.9 mod 54 is 1. In that case, 7 is not generated. To continue with that way, we obtain 5, 11, 23, 29, 41, and 47 all are generator of 54. So the next theorem will tell you the how many generated in Z and static if Z and static is cyclic. So if Z and static is under multiplication is cyclic, then Z and static has phi of n generated, like phi of 54. Phi of 54 is 18. Phi of 18 is again 6. So if you can see our in from, so this has basically 6 generated. And from previous example, if you can see, the generators are 1, 2, 3, 4, 5, and 6. So this result, basically this theorem tell you the direct how many number of generator are possible under mod and in unit element of Z and static. So let us define ultimately the today the aim of class. What is the aim of our today class? Today class aim was is to define discrete log problem over Z and static. Given that n is 2, 4, p raised to power k, 2 into p raised to power k, 4 k belongs to natural number and p is any odd prime number. Alpha belongs to Z and static is a generator. Beta belongs to Z and static, not necessarily a generator. Compute log of B to the base alpha. That is to find x between 0 to phi of n minus 1 such that alpha power x is congruent to B. In that case, this is basically the discrete log base. So Z and static is alpha power 0, alpha power 1, so on alpha power phi of n minus 1. So this is more generic result as compared to Z and ZP static. Let us find discrete log 47 under to the base 17 is Z50 static. First, we would like to check V and static or not, and alpha is a generator or not. First, we have to calculate 50 can be written as a product of 2 into 54. So this is the case 2 into p power k. So Z50 static is cyclic. Check alpha 13 is a generator or not. Alpha 5. So alpha 50 can be written 2 into 54. So 2 and 5 is relatively prime to each other. So you can write phi of 2 into phi of 5 square. So phi of 2, since p2 is prime, so phi of p equal to p minus 1. In that case, 2 minus 1. Phi of p raised to power k, it is p raised to power k minus p raised to power k minus 1. In that case, 5 to the power 2 minus 5 to the power 2 minus 1. So in that case, if you can see here we have 20. So in here in Z50 static, we have basically 20 elements. So the prime divisors of 50 are 2 and 5. So it can be written 2 raised to power 2 into 5. So 20 divided by 2. Basically, this phi of 50, 20 divided by 2 is 10, and 20 divided by 5 equals to 4. Because why I'm calculating this? Because I have to check the number of Z50 static, some different number of Z50. Either these are generator or not. So, dear student, let I take it as from previous theorem. If you can look over here, this one, I have to basically I first of all calculate phi of n, then the prime divisor of phi of n. So I just take it like this one. So I just took to the power, prime power or divisor of some prime. So uh, 20 divided by 2 and 20 divided by 4, I get 10 and 4. So if you can look over here, 13 power 10 mod 50 is 14, which is not congruent to 1. 13 power 4 mod 50 is congruent to 11, is not congruent to 1. So 13 is a generator. So in that case, 50 static can be generated through all the power of 13. 13 power 0, 13 power 1, 13 power 9, 20 minus 1. So 19, which generate are the element of Z50 static. And Z50 static, by the way, have 20 elements. So in that case, if you can look over here, 13 power, we subsequently calculate all these power of 13. 13 power 2 mod 50 is 19. 13 power 3 mod 50 is 47. So I have to calculate log of 47 under mod 3, which is 3. Because the on which power we get 47, the exponent is 3. In that case, we will get 3. So log of 47 to the base 3 is to the base 13 is 3 and C50 is 10. So dear student, these are some other example. You have to do it in under module 7, how to calculate discrete law. Also these are some properties. So discrete log problem has same complexity as factorization problem. So these are some references from where I have take some material, and the rest are all what you call the. So keep this thing in your mind. These are quite the last four lectures, perhaps are quite important lecture that basically give you the basis of public key cryptography. In next few lecture, we will formally start public key cryptography, and with the help of all these, what you call the last four lecture, we will be quite easy. It will be quite easy for us to define public key crypto system, and we will, inshallah, implement all these public key crypto system. Uh, on some digital media like image, audio, and video. Till then, Allah Hafiz. Please stay at home. May Allah bless you all. Allah Hafiz.